this video, I'll show you how to add these improvements to our already existing Unity car controller that we made in the previous videos. In this video, we'll make improvements to the traction control. We'll add mainly an engine with RPM, gears, and other features. And then we'll also add improvements to the skid marks and various other features to the car controller, as well as this UI that shows a bunch of information about how it works. Okay, so we're here in the previous project that we made in the last video. If you'd like to see how we made this, you can check out the link in the description, but this is just the basic car driving setup here. We'll just add in all the features that I showed you in the intro. So we'll start off by going into the code here. This is the car script right here that we made, and now we're gonna go through and make some changes. So let's start off by, we'll add 2 lines. We're gonna be using Unity Engine events and the input system. Actually, we don't need the input system yet, but so the first thing we're going to do is we're going to add a public class engine, and I'm just going to paste in this code and just go over it. So basically where you see green here, this is stuff I added, and I'll just go line by line right now. So we have this public class engine, and we have a few parameters here. We have a public float idle RPM. So this is going to be like the minimum RPM when you're not pressing anything. We have the max RPM, which is where it's pretty self-explanatory, the max RPM, you can't go above this. Then we've got the gear ratios. This is just an array of floats. You can modify this later, but basically this is the first gear, second gear, third gear, etc. We've got the final drive ratio. This is basically just like a ratio that affects all of the gears. And then we have just a private in the current gear, and it's the first one, the 0th one by default. Then we have a boolean for automatic transmission. This is set to true by default. You'll see how this works in a sec. And then we have this private bool switching gears. So this is true only in the moment that we're switching gears for those 180 milliseconds while we switch. And that brings us to this variable, the gear change time. So this is how many seconds to switch gears. Next, we have this private float RPM. So this is just the current engine RPM. And now here we have a public float set RPM, and here we input the average wheel angular velocity. So if you remember how the code works from last video, each wheel has its own angular velocity. And so basically in our update method, or fixed update, we'll see, we basically average out the wheel's angular velocity, and then we input it into the set RPM. And then it uses this to basically convert from angular velocity to revolutions per minute. So this is just a little bit of math. Multiply by 60 and then divide by 2 pi. And then we've got the total ratio, which takes into account our current gear and also the final drive ratio. And then it gets the transmission RPM, which takes in, which just uses this total ratio times the average wheel RPM basically. And then we use a mathf.max, idle RPM, and transmission RPM. So this basically just limits the minimum to be idle RPM to not go below that. And then we set this .rpm to the idle RPM, and we just clamp it between idle RPM. No, we set it to target RPM, but we clamp it between these 2 values just to be safe. And now we also have a public float get current power. So this is used later to calculate how much power we've got available to each wheel. So basically, when you've got a higher RPM, you have more power available, generally is how it works with cars. In this function, you can add in torque curves or like power curves to get more realistic behavior, but this is just a simple setup that works reasonably well. It just returns the RPM divided by the max RPM, so it just looks like a linear chart. If I just draw here, it literally just looks like basically this. So this is the power, this is the min RPM, and then this is the max RPM, and it's just a linear line. It gives us more power when we've got more RPM. More realistically, it's like something like this, and it's like curvy and not exactly straight. That's like a more realistic thing, but yeah, that's how we have it here. Then we've got the angular velocity to RPM. So this is just a function that we use to convert angular velocity to RPM. Of course, we could use it up here, but I just decided not to. And then we've got two functions, up gear and down gear. So basically what these do is first we check if we can switch gears. So like for example, if we want to go up a gear, are we below the max gears? Or if we want to go down a gear, are we above the minimum gears? And then we also check if we're currently switching gears, because we don't want to switch while we're already switching. And then we basically increment or decrement respectively, and we set switching gears to true, and then we run this line of code which basically sets a timer to reset this to false. And you'll see this right here. It's a private system.collections.iEnumerator. Honestly, if you want to learn more about this, go read the documentation. But it basically uses wait for seconds and takes in the gear change time to wait that many seconds, and then it sets it to false. Now we've also got a few more useful functions here. The get current gear just returns the current gear and makes it one indexed. The check gear switching just basically we run this like multiple times a second, like 60 times a second or something, and it just checks if it's in automatic, then we will basically like switch gears like in the correct way. Like if the RPM is above 95% of the max RPM, then we'll switch up a gear. If it's below 60%, then we'll go down a gear. And actually we do need a line here to check if we have automatic transmission on, but I'll just leave it like this for now. You should probably add that in here. And then we have a public float get RPM, and a public float is switching gears to check if we're switching gears, just as useful functions to check externally out of this public class. All right, so now the next thing we need to do is we're also going to make a few adjustments to our traction control. So we'll come down here and we'll add this hide in inspector public float slip history and set that to 0. And we have a public float traction control reduction, set this to 0. And then this we don't need. So yeah, that's basically what we need here. And then in our public class car, we're going to have a public engine E. We just call the engine E to keep it short. And then I will also just change this a little bit to some values like that, the static friction and kinetic friction. And yeah, now we'll go down and we'll also just add, under the assists, we'll just add a float steer assist strength, and this will be a slider from 0 to 1, so you can change how strong the steering assist is. And then we'll have a public float for braking. Sorry. Is braking, set that to 0. And then we'll have a few more things here that are generally useful, and I'll explain these later on, but we'll have a center of mass offset, just set it to this by default. We'll have an inertia multiplier, and then we'll have a raw input. Actually, we don't really need this, but yeah, we'll just have these two, and you'll see some changes that we make here. So now in our start, there's a few things I want to add in the start. Replace these with these basically, and we also added this for each. So I'll just go over what this code does. So we go through for each wheel, we set the traction control and the slip history to 0, just to initialize it. And then here in the rb.center of mass, we'll add our offset, and the inertia tensor will just multiply by the inertia value. And then now we will go down to the void update and add a piece of code here. So this is just a simple block of code. If we get the R input key, we basically just reset the rotation, reset the position up 2 units, set the velocity to 0 and set the angular velocity to 0. So if you press R, you can just reset the car like if you flip it, so you don't need to exit out of play mode and whatever. It's just a convenience thing that we have here. And now we will add a few more things here. But we do want to make a few changes here in the traction control. So I'm actually going to copy this whole block. You can see here where we had it before, float max slip equals 0, all the way down to the end of the void update. And I'll just replace it with this. So basically now we get the input like before, and then here we go straight into a for loop. So for each wheel, we basically have, we ensure there's not a number values from previous frames. This is just a safety check. And if so, reset it. Now we have like higher performance bool and float. Okay, I'll fix this in a sec. Traction control and ABS. So generally the way this works, I might make a whole separate video explaining this, but basically there's this traction control limiting factor, and you move this up or down depending on the current state. Like, is it slipping? Does it have too much traction and you want to push it harder, etc. So I think I'm going to make a separate video just explaining all of this, how, like, the idea behind it and how it works. But for now we'll just move on because that's not the most relevant thing. Okay, we're just going to change this to public float break, and then go down here and set this to w.break is equal to is breaking, but we'll just check if this is equal to true, and then we'll return 1, otherwise 0. So that should fix that. We also just got to check, so we're not going to use the slip angle right now. We'll just set, so here we will just set it to 0. All of this code will be in the description, but if you do want to copy this down, I will just pause here quickly. So get player input, you can see what that looks like. And then all of this, scrolling down, and then this is where the end of the void update. So that's all of the code there. Next, we will continue moving through all of this. Yeah, here at the bottom, we also have a thing to check if you press E or D, this should be Q actually, we will move the gear up or down. And now in the fixed update, we're gonna add a few lines of code here. So we're almost done with the code. Okay, so we'll go into the fixed update. We're going to add a force, transform down, just remove our current downforce. And this will just use our downforce variable so we can change it outside of this script. Now we also have this average wheel angular velocity, which you'll see what that's used for in a second. Next, we actually want to make a change when we check the wheel torque. So we want to multiply it by engine.getCurrentPower and just input this, which is like the current context. Or like, I mean, no, honestly, I'm not sure how this works. But I don't know why we need this, but we need to put this in there or else it will not work. You can check with documentation or other sources about why we need that. But yeah, moving on. Okay, we do want to make a few changes to the skid trails now. So come down to where this code is. Basically, before we had this problem where if you accelerate and it slips for like 1 unit of time, it just adds in a skid mark without properly orienting it. So here, we will, right below setting skid trail auto destruct to true, we will set skid trail dot emitting to false. And then we will also set the skidtrail.transform.position to hit.point. Yeah, that's basically it for here. Okay, now we also want to change this line here. Just remove it and change it to this line, basically. And then remove what we have down here. Oh, sorry. I misspoke. Keep this all the same, just don't make any changes. Okay, so now come back down to your the bottom of your fixed update, and right before you set the wheel visual rotation, we will divide the average wheel angular velocity by wheels.length and set the RPM with our function that I mentioned earlier. So now we'll go back into Unity, we'll see if we have any errors, and we'll quickly fix them if we do. Just click yes if that shows up. Change this from braking to brake like we changed it earlier. Okay, and now if we go into Unity, okay, just come down here and just make sure you move your that code out of the for each loop and just set it down here into the fixed update. That's one change we have to make. One more thing, come up to your the top of the script and just write system.serializable above right above public class engine. And now our code works. So if we accelerate, you can see how the power is not always the same. As our RPM goes up, it increases. And yeah, that's basically it. You can see here, come in and edit different parts of your idle RPM, max RPM, your gear ratios, etc. So now I'll go into doing one more thing. So I want to make a script for the UI, like showing your RPM and all that stuff. So just come over to your car, press add component, and we'll just call this UI, both lowercase, and create new script, create an add, and then double click it to open it up in Visual Studio. Now here, I will just paste in the code and then explain it as I go through. But for now, let's just see what it actually does. So I will make a quick adjustment here. So first off, we need to go into the cars and make sure our rigid body is public. So go over here to the rigid body, and I'll actually hide it in inspector as well so it doesn't show up in the inspector. So that should be good. We don't actually have a slip angle, so I will remove that as well. But yeah, it should be good now. All of the code is in the description. You can check the link to the GitHub repo. So if you see me copy and pasting, you can check out the code there as well. But now when we run this, it shouldn't work because we haven't created our UI. So go to create UI, TextMeshPro. You might need to install TextMeshPro. Yeah, as it shows you here, this will come up. So press import TextMeshPro essentials and the examples. I don't know if you need the examples, but just download all of it. Why not? And then we have our text here. So first go to the canvas and set the constant pixel size to scale with screen size. And then also the text, you can just move it the X position, like in a little bit to be closer to the middle, move this up. And now basically all we have to do is go to the car where we have our UI and drag in this text object, not the canvas, but the text. And now if we click run, we see we've got a lot of information. So, all right, going into the UI script, I'll just quickly go over how this works. So we have this public TextMeshPro GUI, which is the text that we inputted. We also have access to this car, the car script. And then we have a float, a list of an array of floats for wheel slip. And then here we basically get the car component, set the wheel slip, and then initialize them to 0. Then we also have this public void set text, so we just use text.text is equal to new text. So this is just a function .text of these types of items. And then in the update, we just basically do some string manipulation to get a string by accessing various properties in the wheels. So at the end of the day, what we're doing is we're looping through each wheel, adding a bit of text, whether it's like how much is it slipping, the current RPM, things like that. And then we have this final text, and we just set the text.text to this. So yeah. If you want any other Unity topics covered, leave a comment in the description and I'll make sure to make a video on that. Hey, one thing just quickly, make sure you go here and to the average wheel angular velocity, add the wheel angular velocity here. Just write plus equals and just add this single line here. I just missed this. But yeah, that's basically it. This is the full working script. If you have any problems, leave a comment down below. This is a lot of functionality, so I wouldn't be surprised if people have problems because there's a lot of stuff working here to get this all together. Check out the links in the description for the GitHub repo and also my Discord server. You can join the Discord server and I'll try to help you, or other people also working on this kind of stuff will try to help you. And we're just trying to make a community over there. But yeah, thank you for watching and I'll see you next time.